equations and inequalities. So we did those 2 days of working with rational exponents because now you're going to encounter them frequently, but we're going to solve exponential equations. They may or may not have fractions in them because most of our exponentials don't have them, but we had to do all that practice with them because some do, so you need to know what they look like. But we're going to start with simple exponential equations and inequalities we were solving. So the first one we actually kind of talked about a little bit when we did the rules page, the exponent rules page. We briefly talked about this one. These are the easy ones. They're so easy. If the bases are the same, remember the base is what the exponent is attached to. So in this case, both sides, the left and the right, have a base of 3. If the bases are the same, like these are, then you just completely disregard the bases and set the exponents equal to each other. So if the bases are the same, the bases don't even matter. And you can just solve this like a regular old 8th grade equation. And I got x equals 4. Everybody okay? So that's the very easiest. Now here's what's going to happen. We were talking about this last period. These are so easy. And I'm not going to tell you that they're not, that it doesn't stay easy. They stay pretty easy. But the problem is the bases aren't always the same, which we'll get to one in just a minute where the bases aren't the same. We'll rewrite the bases. And then we'll get to one in a minute after, well, not today, but in a few weeks, where the bases can't even be made the same. And you have to solve them a different way. The problem happens that once we learn new ways to solve them, you forget the very easy way. Don't, because it does come up. There are problems like this that show up on the SAT and the ACT. So just because they're easy doesn't mean that they're not going to show up again, and it also doesn't mean that you're going to remember how to do them, because what happens to us is we let the hard stuff make us forget the easy stuff. So don't do that. If the bases are the same, you disregard the bases and just solve them. On problem number 2, the bases are not the same, but we can rewrite them with a common base. So we can find a way to rewrite one or both of them with a common base. Now, a couple of things about rewriting bases. Number 1, you never go bigger. I will never go from a 3 to a 6 or a 9. If you're rewriting a base, you always make the number smaller. The next thing about rewriting bases is, let me explain, because I had to do this a little later in the second class. Let me explain exactly what bases are. They're big numbers with exponents attached. So 1 squared would be 1, 1 cubed is 1, 1 to the 4th is 1. That one's pretty easy. 2 could be our base. 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, and so on and so forth, right? I could do 3s. 3 to the 1 is 3, 3 squared is 9, 3 to the, I skipped one. 3 to the 3rd is 27, 3 to the 4th is 81. So if I encountered a number like 27, I could rewrite it as 3 to the 3rd. But notice, so far, on the right-hand side, do you see the number 6 anywhere? So 6 can't be rewritten. It doesn't have, there is no base that can make a 6. 5. If you look at all these, do you see 5 anywhere? 5 can't be rewritten because there is no base that would make a 5. Y'all following? 7. 7 can't be rewritten because there's no base that would create a 7. I mean, I could do my 4s. 4 to the 1 is 4. 4 squared is 14. 14 really. 4 squared is 16. 4 cubed is 64. You can do your 5s and your 6s and your 7s, but you have to be aware of what things can be rewritten. All right, now this one, 1/9 cannot be rewritten necessarily, but 9 can be. So I'm going to do this one in 2 steps. So the left-hand side is a base of 3. I don't want to change that one because it's already small. I can't make it any smaller. That base is fine. It's this one that needs to be changed. and I can write 9 as 1 over 3 squared. Is everybody good so far? Understand that I've just rewritten 1/9. You haven't changed it at all, you just rewrote it a different way. Now, the problem with this is the left-hand side guy lives upstairs, the right-hand guy lives downstairs, and they need to be on the same level in order to operate them. So I'm going to flip this one over. And when I move this 3 upstairs, what happens to your exponent? It becomes negative. And now you have like bases. So you can disregard your bases. And just solve this equation. And I got x equals 0. Okay, so far so good? Not too bad, right? Alright, so tell me what I'm going to do on number 1.
7 equals 0.
Just set them equal to each other, right? Because the bases are the same. And if the bases are the same, you don't even need them anymore. So I just have x minus 7 equals 2. So x equals 9. Alright, so on number 2, I do not have like bases. So I'm going to try to rewrite them with the same base. And this is where it goes to here. 2 cubed is 8. So I can rewrite 8 as a base of 2. So the left-hand side already had a base of 2. Now the right-hand side I'm going to write as 2 cubed. So I have 3x minus 4 equals 3. Because once my bases are the same, you just solve. So I got x equals 7/3. So far so good? Alright, so on number 3, my bases are not the same. So I'm going to try and rewrite them with like bases. This one can actually be done 2 ways. We're going to try and do it the simplest way. If I look at my list that I made of different bases, 16 shows up twice. It shows up here, 2 to the 4th, and it shows up here, 4 squared. Well, my right-hand side already has a base of 4. So if I use base of 4, like this one, then I don't have to rewrite the right-hand side. You could, but you don't have to. So I'm going to rewrite the left as 4 squared, and then don't forget that 2 minus x was already there, so I'm going to put that piece in parentheses. And now you can disregard the bases. I'm going to go ahead and distribute my 2 when I put the equation together. And now you're just solving. So I get x equals negative 1. Everybody good?
Do you ever have to say these for?
Oh, that's a good question. For extraneous roots? Nope. These don't generate extraneous roots. Now, the inverse of these do. So then we'll talk about those probably next week. Alright, so number 4, I have like bases already. So just set the 2 equal and solve. Yes. 8:30. Yes. Dress them down. Okay. Sure. Absolutely. Okay. Awesome. Thank you. I got x equals -2. Kind of did that a weird way. Should have gone the other way. All right, so then we get to number 5. In this case, remember, you always want to try to make your bases smaller if they're not the same. In this case, they're not the same. And there's no way for me to rewrite 27, or to rewrite 81 with a base of 27. 27 squared is already way past 81. So if you look, my first initial thought would be 9, right? We could rewrite 81 as 9 squared, but I cannot rewrite 27 with a base of 9. Because 9 to the first is 9, and 9 squared is 81. So we've gone right past 27. Is everybody following? So instead, if I look at what I made these bases, there's a 27 and there's an 81, both with a base of 3. So that's how you're going to have to rewrite these. So my 81 is 3 to the 4th, and your 27 is 3 to the 3rd. And just don't forget that x minus 1 was already out there. Once you get your like bases, you just set the exponents equal and solve. So I get x equals 7/3. Everybody good? All right, so now you try number 6, because it's a lot like one we've already done. It's a lot like example number 2. At x equals 3. Does anybody have any questions on that one? Are we good? Everybody all right? All right, so flip to the next page. We're going to talk a little bit about using your calculator before we do inequalities. All right, exponential equations can also be solved using your calculator with tables and graphs. Just in case you have forgotten, all equations, it doesn't matter what they are, quadratics, exponentials, radicals, linear, any problem can be solved with tables and graphs in your calculator. And it works the same regardless of what the function is. The rules are the same every time. You put the left-hand side in y1, so I'm going to put 3 to the 2x minus 4 in the left-hand side in y1. And then I'm going to put 3 squared in y2. And then I'm just going to hit graph. And there's the graph. So now you guys tell me, where is the answer to this problem? At the intersection. So all you have to do is second trace 5 to find the intersection. And notice, on this particular graph, somebody was saying last unit was a little bit harder because it had 2 graphs. You know, you just arrow until you just hit the arrow keys until it gets on the graph you want it on. But it says right down here in the left-hand corner, first curve, and it is actually on the curve. You can see it flashing. If I arrow over it, you can see where it is. Hit enter. It jumps automatically to the second curve, which in this case is a straight line. Hit enter, and hit enter one more time, and you get the intersection. X equals 3, y equals 9. Now remember, we are solving this. When you're solving something, what are you trying to figure out? What is x? So the 9 is irrelevant. It's not completely irrelevant, but in this case what we're looking for is what is x. And x equals 3. Now that's how you use the graph. I use the graph first. I always do the graph first, I don't know why. But if I hit second in table, and I'm looking on my table, what am I looking for? How am I going to know I have found the answer?
Why equals 0?
See a long list. Y equals
What?
9.
I passed it.
Oh,
Y equals 9.
Y equals 9. So both your y columns should be equal. If you find the place where your two y columns are equal, then that's the x value that's your solution. So on my table, I'm looking for y1 and y2 are supposed to be the same, so I got 3, 9, and 9. So that's my answer. Okay, so let's do number 2. Same way. Plug it in your calculator. So you're going to put the left-hand side in y1 and the right-hand side in y2. Doesn't matter whether you go to the table or the graph first, whatever you like better.
The bases don't have to be the same.
Do it.
You don't have to make sure the bases are the same.
Nope, not if you use your calculator.
That's pretty cool.
So I got x equals -1. And if I check my table, same thing, you get -1, y1 equals 8, y2 equals 8. Okay, so real quick, this is on any assignment, any test you do, if you're solving, now this is only if you're actually solving, you can use your calculator, find the answer. Now if I've asked you to show your work, you'll only get partial credit, but if you can give me an answer, you're going to get partial credit. So it works for every single function we've done. There's not a function out there that this doesn't work for. So use it, that's what it's for. Okay, so 7, 8, and 9, real quick, use your calculator and find the answers to 7, 8, and 9.
Is the test over this?
We still got several things to do. So probably not till next week. I got -2, 7/3, and 3. Everybody alright? Using your calculator makes this easy. Okay, so far, does anybody have any questions on this? Y'all doing okay?
It's easy.
It is easy. Now, the next thing we're going to do is some inequalities, and this is for things, they're not hard, but I think this is where some of us have a little bit of confusion. So, here goes. Alright, so very similar to finding the actual solution. You put the left-hand side in y1, put the right-hand side in y2, but this time you have to take into consideration what the sign is. So in this case, I'm going to write this. This was what I put in y1. And this is what I put in y2. So they're saying, if you look at it that way, that what's in y1 should be less than what's in y2. Now they've already put the picture of it there on this one, so you don't even have to put it in if you don't want to. If they're saying the y1 piece, which is the curved piece, I can tell that y2, 3 squared is just 9, that's going to be a horizontal line. So what they're saying is that the curved piece has to be less than the horizontal line. So if you're looking at this graph, the part of the graph that I'm concerned with is this piece. Right? Everybody agree that that is less than the horizontal line? Okay, here's where this causes confusion. I am solving this inequality. When you are solving something, you are looking for x values only. And clearly, everything that is on this yellow line has a different x value. So there is not just one answer, there is a range of answers. I need the x values of that yellow line, or the domain of that yellow line. So how far left is that yellow line going to go?
Negative infinity.
Negative infinity. Now, it looks like on this picture and in your calculator, it looks like it kind of stops right there, doesn't it? But it doesn't. And if you're not sure, you can check your table. Because look, this is what it looks like in my calculator, and it still looks like it stops right there. But if I go to my table, there's -1, and it still has a y value, and -2 does, and back, and back, and back, and back. No errors yet. There's no error message here. And I can just keep going, and that x, it's still going in the negative x's. Yes.
How far do those calculators go back?
Forever, as far as I know. I mean, I think you can just keep on going. I've never sat and tried to see how far back it'll go. But as long as there's not an error message, which there isn't, this is still going forever to the left. So I know that it's going from negative infinity, that's how far left it's going, to how far right. So I need to know, where is this point?
9.
Careful.
2 points.
8.9.
Because, well, well, and I know why you said that too. But I'm going to do a second and a trace and an intersect. And this is why I said this is where the confusion comes in. Yes, the y value is 9.
Oh, it's 3 though.
But it's 3 because I don't want the y values. I'm solving this. And so I want the x values. So it goes to 3, but the 3 is not included.
So it's open.
Because, yes, it's open. Because this time it just said less than. So if it had said less than equal to, then it would have been a bracket. But it's not. It's just less than. Okay, so you try number 6. Let's see what you get. Okay, so on this one, I plugged it in my calculator, the left-hand side in y1, the right-hand side in y2. The right-hand side is the horizontal line. So this is saying the exponential, or the curved piece, is going to be greater than the horizontal line. So in this case, I am looking for just this little piece above the line. So I sketched it right here. So I'm looking for this, where it's above the horizontal line. Okay, so I have to figure out, well, where does it start? Where does it touch the horizontal line? How far left is this going to go? So when you're in a second and trace and an intersect, and it does start at -1, because it's the x values we're concerned about. Oh, and this time it gets to be a bracket, because it says it can equal 8, and it equals 8 at -1. Now, how far right is this going to go? Infinity. Now, it looks like it might have an asymptote, but again, you can check your table, and if you check in the, I'm going to go in the positive direction, let's see, from -1, and as I start going through my x values, it just keeps going. It just keeps going forever. So it does go from -1 to infinity. Is everybody okay? Okay, try one more, the one at the bottom of the page. piece is gonna be less than or equal to, so I'm looking for everything below that horizontal line. X values only though. So how far left is that gonna go? Negative infinity to how far right?
To 2 and 1/3.
2 1/3, or it's 7/3, 2.33333, which is 2 1/3. Do I have a bracket or a parentheses here? Bracket. Because it can equal 8, so it can be a solid dot right there. Is everybody good? Alright, so that's not so bad, right?
Very hard.
Just don't let the hard